Imagine a radiant object, unlike anything we've ever had, hurtling through a vast field of space many times faster than a normal comet in our planetary system. This is not science fiction, but a strange visitor arriving in our planetary system in 2017. This new object is the first interstellar object ever observed in our solar system and is called Oumuamua in the Hawaiian language, which means the first to arrive from afar. It has astronomers baffled and has inspired theories ranging from a space rock to a possible spacecraft cruising our galactic neighborhood. Oumuamua was 15 million miles from Earth, many times the distance from Earth to the Moon. Scientists were amazed by its speed. As it circled the Sun, its speed increased, defying the laws of celestial mechanics. Could it be triggered by some unexplored form of cosmic radiation? Or is it a comet producing gases in a way we've never seen before? In a universe ruled by rules and conditions, Oumuamua is a confusing anomaly. A large, rock-like mystery about 650 feet long, a faint streak was spotted by a telescope in Hawaii on October 19, 2017. It was no ordinary celestial body. It was Oumuamua, the first known interstellar object to visit our solar system. Unlike asteroids and comets born from our sun's gravity, Oumuamua drifted from deep interstellar space. Its trajectory indicated that it was not bound by the sun's gravity, making it a temporary alien in our system. Oumuamua is distinguished from others not only by its origin, but also by its unique characteristics. Its elongated shape and rapid rotation do not meet the standards of typical objects in the solar system. The academic community is full of theories and debates about the nature of Oumuamua. Is it a comet with a tail, as its strange rotation suggested, or something else entirely? These questions led to extensive scientific research, leading to several hypotheses that it is part of a larger celestial body and to more speculative ideas, such as that it is an alien probe. The discovery of Oumuamua is a breakthrough in cosmology, similar to when people first looked through a telescope and realized that Earth is not the center of the universe. It illuminates the formation of the solar system and reminds us that our solar system is only a small part of a vast, unexplored wilderness. As Oumuamua moves further away and becomes a dim speck in the vast ocean of space, the desire to study it grows. With improved telescopes, we hope to learn more about these interstellar messengers, providing new insights into the structure and history of the universe. Further study of Oumuamua reveals fascinating details. It was originally classified as a comet, but it did not have any of the usual comet-like features, such as a bright coma or tail. This led to its reclassification as an asteroid, but it's not just any asteroid. It is an elongated object unlike any asteroid we have seen before. Its unique shape has led to various hypotheses, including the possibility that it is an alien spacecraft. Scientific publications describe the physical characteristics of Oumuamua in more detail and note that the object does not rotate, which is unusual for both asteroids and comets. This ripple motion may be due to a collision with another celestial body, although this is purely speculative at this point. Oumuamua's trajectory presents another mystery. It entered our solar system at an unusually high speed and followed a hyperbolic trajectory indicating that it would never return. Most objects captured by the gravity of a star move in an elliptical orbit, but not Oumuamua. According to the researchers, non-gravitational forces affected its trajectory, which could be inferred from the release of materials caused by the rapid outflow of gas. However, no such gas emissions were detected, further adding to the mystery. The absence of a visible coma and the high speed of the object led to various theories. Every detail revealed about Oumuamua adds to the mystery and encourages further research and hypotheses in the academic community. Some scientists suggest that it may be a fragment of a larger object that disintegrated. Others believe that it can be a new class of object, different from a comet or an asteroid. Some even consider the possibility that Oumuamua is a solar sail carried by radiation pressure. The fact that the speed of the object could turn it into the core of another star system, which could be ejected from a planetary system orbiting a young star, suggests that Oumuamua may be one of the first interstellar objects observed, a remnant from another part of the universe. The story of Oumuamua is a cosmic detective story where every piece of information only deepens the mystery. Its elongated shape is unlike anything we've seen in the solar system. Could this unique shape provide advantages for interstellar travel, such as reduced drag or increased stability, or is it the result of some cataclysmic event we still don't understand? Its trajectory adds another layer to the puzzle. The lack of a visible tail rules out the possibility that gazelle throws affected its path. So what non-gravitational forces are at play here? Could it be affected by dark matter or some other unknown cosmic anomaly? Theories surrounding Oumuamua range from the plausible to the outlandish. Could Oumuamua be a herald, the core of another star system? The possibility that it's a solar sail is particularly intriguing, and although it's never been proven, it could change the way we think about space travel and open up the possibility of interstellar radiation-powered ventures. When studying celestial objects like Oumuamua, astronomers rely on a variety of tools. The study of the nature of Oumuamua was led by a team of experts, including Jennifer Bergner, a physicist at the University of California at Berkeley. Bergner and his colleague, Cornell University astronomer Darrell Seligman, were at the forefront of unraveling the mystery of the object. Their work, published in the journal Nature, is considered the most convincing model of the origin of Oumuamua. According to European Space Agency astronomer Marco Michel, NASA's Hubble and Spitzer telescopes supported the team's observations, showing that Oumuamua was strangely elongated and slightly accelerated when it left the solar system. This increase in speed is often seen in comets as they expel ejected material, but Oumuamua did not show the kind of emission of dust and gas or a visible coma we might expect from a comet. The team used modeling to show that Oumuamua may have originated as a typical water comet that orbited a nearby star before being ejected from the system. High-energy cosmic rays may have converted up to 30% of the comet's water ice into hydrogen, which may have been trapped in Oumuamua's ice as it traveled through interstellar space. As it approached the Sun, the trapped hydrogen would have been released, giving the object the acceleration that Seligman observed.
The team's hypothesis explains all the unusual aspects of Oumuamua. This indicates that Oumuamua was indeed a comet, albeit an unusual one. The lack of a visible coma or tail can be explained by the fact that molecular hydrogen is much lighter than the materials emitted by typical comets and therefore does not collect much dust. Although Bergner and Seligman's hypothesis is compelling, it is important to note that not all of the research community is convinced. Astronomer Karen Meach of the University of Hawaii at Manoa continues to believe that the standard model of the comet may be valid. He speculates that Oumuamua may simply have a small amount of dust, which would also explain the lack of a visible coma or tail. Another theory that Oumuamua may be an alien probe has captured the public imagination. Its elongated shape and strange trajectory led to the hypothesis that it may be an artificial object. This theory gained some traction when Harvard astrophysicist Avi Loeb suggested that Oumuamua may be a thin, flat, almost rectangular object, possibly a probe sent by an advanced civilization. Loeb's hypothesis received widespread media coverage, fueling speculation. Although the space probe theory made headlines, it did not stand up to scientific scrutiny. First, if Oumuamua was a probe, it would probably emit some kind of radiation or signals that would be detected. Additionally, its bag motion doesn't match what you'd expect from a probe designed for smooth motion or data acquisition. In addition, the trajectory of an object can be explained by natural phenomena, as previously mentioned. Jennifer Bergner and Darrell Seligman's hypothesis that Oumuamua is a hydrogen-rich comet explains its unique properties and does not require extraterrestrial intervention. The idea that Oumuamua may be an alien probe reflects our collective interest in the unknown and the possibility of intelligent life beyond Earth. But it is also a warning about the importance of rigorous scientific research. While speculative theories are interesting, they can distract from more plausible explanations. Although Oumuamua's unique features have puzzled astronomers, the most likely explanation is that it is an unusual comet or asteroid. Its long journey through interstellar space likely changed its composition, forming an outer surface that retained most of the frozen gas. This theory explains the unique features and is supported by observations from NASA's Spitzer Space Telescope. The discovery of Oumuamua has a major impact on our understanding of interstellar objects. This suggests that trillions of such objects may be traversing our solar system, and we are just beginning to discover them. The Large Synoptic Survey Telescope, LSST, in Chile will receive its first technical camera illumination in December 2023, and full measurements will begin in October 2024. Once LSST is operational, it may be able to identify additional objects like Oumuamua.